So what's happening is, as this rope spreads apart, your resistance is changing. Actually, the amount of effort required of you is what's changing. And let me try to explain how that occurs, if I can, in some kind of simple fashion. First, look at the simplest thing to start with, kind of the baseline. Look, if you have a cable that's pulling at 50 pounds is what you choose, and you put a bar on it, and whether it's a bent bar or those angled tricep bars or a straight bar, it doesn't matter. The point is that it doesn't give, right? It perfectly transmits your effort. So what that means is you get to push straight down with each hand, and if 50 is what it takes, if 50 is what you chose going up, 25 is what it's going to take from each hand, because they're both working in a sense as if they're pushing straight down directly against that cable, right? So hopefully that makes sense. But what's happening in this thing that spreads apart? Well, it's very, very different. Your effort is not pushing straight down. This example I drew right here is a 30-degree difference or 30-degree angle between the two sides of the rope. So you're pushing off at a distance a few degrees from straight down. That means your effort is in a sense divided. Part of your effort is straight down, and a small part of your effort is no longer helping to move the thing. A small part of your effort is now trying to spread the rope apart, okay? So at a 30-degree angle between the two sides, it actually requires 26 pounds from each hand. In a sense, 52 pounds is what it takes from you in order to hold 50 pounds from the cable. And I've got a little drawing right here. You might be saying, what does that say? Well, don't worry about it. I'm going to read it to you. You don't have to see it. If you want to know what it is again, rewind what I'm getting ready to tell you. But the downward part of this is always going to be 25 pounds. The outward part, in this case, is 6.7 pounds of effort outward. Okay? Well, the resultant, or the angle between that, ends up being 26. That's where these numbers come from, okay? So let's move on. Let's say you're going through the motion here, and now as you go through the motion, it spreads apart a little further. You're at the point in the development of this exercise where you're about 45 degrees between the two sides. That actually takes 27 pounds of effort from each hand, force right there. And in a sense, that 50 pounds now feels like 54 to you, all right? You got still 25 pounds of your downward effort. That's always going to be what it takes to offset the 50, 25 on each side. But now, all this extra effort went to spreading it out wider, actually about 10 pounds of effort on each side, spreading it out. Now, you don't just add the 25 and the 10, because it's a trig function between the two, a mathematical function that, like I said, is about 27. Again, we're progressing along. We've got 60 degrees between your hands now, between the rope. What happens now? Well, it's going to take 29 pounds of effort on each side. In a sense, 58 pounds of effort total combined from you to lift 50 pounds. All right? Small numbers up here, just notes to myself. You got 25 pounds down on each side, and 14 and a half, or actually 14.4 pounds straight out. And again, if you can't read that, just listen to me. I keep saying that because people call us up all the time and go, I couldn't see what you were talking about. I couldn't read it. That's why there's also sound on the tape. It's really helpful that way. Let's take a look at we're progressing along here. Look at this. You got to spread apart now so that it's a 90-degree angle between these two. There wasn't much change. When you went from 30 to 45 to 60, you notice that wasn't that big a deal up here. It starts to change big time, though. When we start getting near 90, look what this takes. And obviously, there's as much effort outward as there is downward now because of how far you got this thing spread. 25 pounds still on one side to offset the 50, 25 and 25 downward. But there's also 25 and 25 outward. All the trig functions we will sit down with a calculator and figure out. That's actually going to require 35 pounds of effort at that angle from each side. In other words, this 50 feels like 70 to you right now. That's a lot. Well, how could somebody even do that? If 50 pounds was pretty good for their workout, how could they move 70? Well, you watch people that do this. Typically what they're doing, they're either going real fast at the beginning or they're actually using like hip muscles or something. You know, you've seen them. It's like this whole total body thing. So they get that weight traveling, the inertia of it, right? the weight's happy to keep moving on its own a little bit, so that's how they make up for that extra 20 pounds, 10 from each side, that they couldn't normally do because they used other muscles. Well, that's great if we're trying to do triceps and hip flexors all in one wonderful exercise, but I don't know if that's the idea. Let's progress a little further, because you remember in my example with my little short version of a rope I was showing you with, I could spread it apart pretty far because it was such a light weight, but that wasn't a light weight by the end. If I had 50 pounds pulling up and I spread that thing way apart to where there's 120 degrees between the two sides, that's 100 pounds of total effort, twice as much as on that cable. This is why I always say the amount of actual resistance you've got over there, the numbers painted on the machine, is no indication of the actual forces that are on your body. 50 pounds of effort from this cable actually requires 50 pounds from each hand. So you're either cheating like a big dog, or you've got virtually no resistance when you start at the top if you could actually do this at the bottom nice and slow, if that makes any sense. Now, the big problem here is with these ropes, you really do have to spread them apart a long ways, and part of it's because they're so darn short on each side. In order to get your hands halfway underneath your shoulders, right? Well, that rope's spreading way apart. That's one reason that we decided to make a handle that was much longer on each side, not only so you could use it for many other things that we'll show you in a minute, but also so there's a more consistent resistance, okay? Now, let's say you're saying, Tom, I don't always use 50 pounds, so I could just kind of look at the theme of this, and basically I could realize that regardless of the weight I use, when I get to spreading it apart about 120 degrees, it's basically going to double my resistance, the sensation of the resistance that required, right? I could basically use that theme. So if this was 20 pounds up here and I spread this rope apart to 120 degrees, yeah, it's going to take me 20 pounds from each hand to move it, 40 total pounds. Well, if you have a calculator sitting around, one of those calculators with the little trigonometry functions, the sine, the cosine, the tangent, and all that stuff, and even if you never knew what those meant before, now you get to use them, okay? I'm going to show you just how to do it. I've got a little equation for you up here. Oh, my marker's dead now. We've got a little equation up here. And what we do, take the amount of weight you choose. Okay, so if it's 20 pounds or 200, doesn't matter. Put 200, if that's the weight, put it in the calculator. Then push divide. You're going to divide by. And then we got to find half of this total angle of spread. So as I spread this apart 120 degrees, I'm going to take half of that. In other words, if I was going straight down from the cable and over, that'd actually be 60 degrees. I'm going to take 200, divide, push the little cosine, COS, and then push 60, which is half of my angle here. Push equals. Next thing you know, you're going to get the exact amount of total weight, not how much was in each hand, but you're going to get the total that it's going to take combined from each hand. If you want to know how much each hand has, just obviously divide it by 2. So if that all seemed confusing, rewind it. That's the wonders of video. But now I want to show you what happens when we actually make it a little longer on each side with our split double handle webbing.